Greg Armstrong with Proteor. What are a couple other really good mechanical needs that Proteor has?
Most widely used is it's a 6-axis that provides a very reliable geometric lock during stance phase. And so you have a adjustability for the amount of preload for the stance flexion, as far as the preload on the flexion bumper. The nice thing about it being a 6-axis knee is you get the high confidence in the geometric lock. It's not super sensitive to alignment, but you still get the easy initiation of swing phase. So a key benefit to the Symphony is it has, hard to see in contrast, the full extension lock so that the patient can walk and then just a simple flip of the switch, and now it's fully locked in extension. So if they're walking through thick brush, snow, climbing ladders, anytime they want to make sure that the knee is completely stable, very easy to actuate through clothing, and has a very nice quality feel to it. Adjustments are easy to access through the frame, flexion and extension adjustments.
So hydraulic swing.
Hydraulic swing phase. The design of the hydraulics is designed to be very efficient. So nice, short, small steps, has very low level of resistance. And then when they walk faster and the knee flexes beyond 40 degrees, it has a much higher level of resistance. Kind of microprocessor control in some ways in how it regulates that hydraulic resistance.
Let's talk about the ALLUX 2.
Key differences between the ALLUX 2 and the ALLUX 1 is first upgrade of the wireless technology. ALLUX 1 is programmed wirelessly, uses a remote control to change modes, but it doesn't use Bluetooth. ALLUX 2 will be upgraded to actual Bluetooth, so it's more compatible with both programming by the clinician using a smartphone app, and the wireless remote control will also disappear from for the user, and they will change modes using wireless app as well.
User app also, they can relabel their modes from like free swing, they can call it biking. I think instead of fixed angle lock, maybe you're calling it party dancing mode or something.
No, that's what I called the my normal walking was just party mode, and kind of a running or more aggressive mode.
The user can actually just change the name to what reflects their activity.
If they have their knees set up for various shoes, they can assign one. All right, this is my church settings, this is snow boots, hiking, instead of it just being listed as a normal walking mode. The user to have access more to their step count data, so they'll actually through the app see the total steps on the knee, the number of steps they've taken in that day, and then a kind of a trip odometer, which allows them to reset a step counter, measure whatever number of steps they want at any given time.
155 to about 180 degree max flexion, which not everybody, longer limbs aren't going to achieve 180 without hitting the back of the socket, right? But 180, you got what you can show that?
180 degrees of total flexion.
Yeah, so 180, very cool. So the linkage bars look a little different, and we're going from a bushing in some of those axis points to needle bearing, right?
Yeah, so the front linkage will be upgraded to needle bearing, be a little bit more durable. Water resistance has been upgraded. Still only splash resistant. It's still not submersible, but a little bit better water protection rating as a result of
bearing question. We really didn't see any problems with the bearings on your average, moderate, and low K3 users. We really saw on the high 14, 15 hour a day guys are out there just going, right? No reason to say that ALLUX 1.0 on our average K3 is not durable enough. I mean,
right, it just gets better. So yeah, existing ALLUX 1s, they excellent for most of your average K3 users. It's just those that are, or maybe K4 might see a little bit higher maintenance on their knees. The ALLUX 2 should be reduced because of the needle bearings.
The programming app, we're going to have, so if you're already familiar with ALLUX 1.0 and programming on a PC programming is going to go away for the 2.0, but we're going to have a programming app. But it's basically the same feel.
The methodology, all the settings are the same. It's just a different interface. So you still set a toe release point. You still have stance flexion, stance extension, swing flexion, swing extension, and then a safety lock level, and then a dead battery level. I still go in into the remote control, the different modes for your users. You'll still have the ability to create a gait report, 2 years worth of gait data, and you can print out gait report that way and transfer knee settings from phone to say a demo knee.
Right. So a little bit better splash resistance, a little bit more durability for our higher active individual, app programming, but the practitioner won't be able to go back to the PC with the 2.0. Is that correct?
Correct. Yeah, the programming from the PC or from the user using a remote control, that goes away. That will not be.
And we're working on training. We work partner with you, and we work together on some training. Well, there's one other question I want to ask you just real quick, because I think we have time in this. Hydraulic knee, stance control knee. You've got one, right?
Yeah, that would be the hydraulic stance and swing knee. A nice feature. This knee has been actually upgraded. The nice thing about this knee is it's a great alternative to microprocessor controlled knees, because stance phase engagement is really predictable and reliable because it's weight activated. Most of your stance and swing knees that are available are default stance phase, and they rely on some trigger, usually a hyperextension moment, to disengage that stance phase. But as such, it's easy to trick. Personally had those types of knees buckle when going downstairs on me. With this, it's weight activated, so there's actually two different articulation points within the knee. You only see one of them. But once a load is placed on the knee, it shifts the linkage and changes it from default swing phase to then stance phase. And you can adjust the sensitivity of that using a little adjuster on the back of the screw. So this one here will adjust the stance phase sensitivity when it gets engaged or disengaged, followed by the level of resistance and then your swing phase adjustments. And then there's an easy to actuate manual lock, and you can lock the knee at, it's actually locked right there. So you can flex the knee and then activate the lock, and it's locked at wherever you want.
If it's locked, is it locked to extension and flexion?
No, it's just locked to flexion.
If somebody was somewhat sitting down, locked it, could they use it to stand with?
Yeah, it could be a sit to stand feature. It could be a really great solution for a bilateral that may not want microprocessor control. Activate that lock and sitting down. It extends.
Yeah, that's a huge aspect for bilaterals. And then once they unlock it, then they got hydraulic yield sitting down, right?
Correct.
Everybody thinks weight activated. You're automatically saying weight activated locking, but you're saying weight activated hydraulic yield. Sitting into a chair, descending stairs, just like we set up our microprocessor mix, right?
Yeah, so that's why I said it's a really great sub-4 microprocessor. High weight rating, 330 pounds. Great for even the more active individuals. That fairly compact and relative to other competitive knees.
So that distal attachment, is that 30 millimeter?
Yeah, it's a 34 millimeter clamp. We really recommend using either one of ours. It's more of a thin wall, 34 millimeter tube clamp. Some thicker walled will make contact to the bottom end of the hydraulic unit, will cause the knee to melt.
Definitely something to be want to watch out for on that. And so for everybody just joining us or in the recording, what's the name of this knee again?
This is the Hytrek.
Hytrek. Well, I think we're about out of time today.